So good afternoon, everyone. We're going to continue our discussion on multiple linear, machine learning for regression. We loaded these packages already last time, and then we loaded the start date and end date from 2015 to 2024, and then we we uploaded the USD PHP data from Yahoo. Okay, we preserved the whole data. And then we also created an object that has only the closing price. And we said that the USD PHP closing price had three missing values, while VIX, on the other hand, had 92 missing values. Brent oil price has two missing values. Now we're going to merge this into one because we're going to use regression where the dependent variable is USD PHP return. So either when we compare the missing values, VIX has the largest of 92. So we said that if we were only modeling VIX, then we could have just used the uh, na.locf function of zoo, which allows us to forward fill uh, and impute on the missing values. So here, the last observation, the value before the missing value will be imputed on the NA values. And we run this class, and when we do LOCF, we saw that now the VIX data has no missing values as against here 92. So that's what happens when you perform LOCF. Now we were we we had the dilemma whether to first perform LOCF on VIX and then merge the data with USD PHP and Brent, or use the original VIX and then merge it with Brent and PHP, USD PHP. You can use the merge function and then omit the missing values. Okay, so this is what we call inner join. This whole process is called inner join. Okay, so as we said, if we were only doing a univariate Garch analysis for VIX, then this would have been perfect. But we're not doing that. We are doing a multivariate, sort of multivariate analysis because we're doing regression, multiple linear regression in in using ML, machine learning. So when we performed this, we saw that the the merged rows had 2915, and then when we performed the inner row, inner uh, inner row class by deleting the missing values, we only have 2214. We computed for how much data was retained, 76%. Now we'd like to compare this if we if we okay, here we created the LOCF, okay, and then we merge it, okay, okay, we run this first. So before the LOCF, there were 92 missing values, as we have already shown above, and then after there were zero, therefore 92 missing values were filled up. And then we merge this with USD PHP and then the Brent. Okay, let's do this. Let's merge this. Okay, and then okay, compare it with the compare it with the where's that? Is it here? Okay, no. Let me run this first. Okay. This was the original class. The sorry, excuse, I'll just drink water. Okay, so this was the merge price class, the one where we where we merged the original VIX with the USD PHP and the Brent. And this one where we first did the LOCF for VIX, and then we interjoined with the dollar rate exchange rate and the Brent. And there were 2015 rows of observation returned vis-a-vis 2014. I'm sorry, class. Sorry, my throat's acting up. Okay, and we said that there's only a difference of one observation. So which is the choice? Quickly, class. We said that doing LOCF class, if it's only univariate class, one variable only, you're not merging it. That's very good. That's okay. However, when you're merging it, take note that we introduce false or pseudo values to it because of LOCF. And then when we do that, and then we merge it with the other data, then that could cause some problems. Plus, so what we did was to use the merge prices. The merge prices is a data. Let's just quickly check. It's an XTS object. And what does it contain? Open, high, low, close class. The complete USD full plus the VIX and the Brent. Okay. This is my question, but mamaya attendance class. Okay. So where was I? Bilang sorry. Okay, so next thing class is we need to compute for the returns, okay, because the uh, we don't use the prices class in modeling time series, especially financial assets. What is normally modeled are returns. So we have learned about this daily return. What we're going to use is the merge prices. This is an XTS object. So when we perform an operation on an XS object, the result will be an XS object. So all of these are XS objects also. So we're going to get the daily return only for USD PHP close, okay? And type is equal to log. And do the same for VIX ret and Brent ret. Only perform daily return for VIX, type is equal to log, and same with Brent. And then we said that for target, what we're going to do is we're going to log, okay? We're going to get the log of USD PHP ret, but it's not K is equal to 1, okay? It's K is equal to -1, which means that the value today will be placed yesterday, okay? So take note of that. The value today will be moved back to yesterday. What's the purpose? So that it will be in line to the values yesterday. So when we now regress this, we are modeling the value today with the prices of yesterday. So that's what happens with when we when we do this, K is equal to -1. And I explained this class here. So that we'll have a one step lead. Okay, it moves the return from the next row up to the current row. Okay. Okay, so when we run this class, we now have these objects, USD, PHP ret, and then, okay, how many, let's see, how many rows does USD, PHP ret have? First, the merge data, I have it here. Merge prices. There are 2214 observations class. So each step of the way, you need to check the number of observations of your data. So our USD PHP ret, how many observations does it have? USD PHP ret here class. Okay, 2014 also. 2014. It's from the merge prices. Now, and we know that when we get the daily returns class, there will be a missing value there because the first observation will not have a prior value. So we need to, okay, what we're doing now here is we're combining, okay, USD PHP ret, an XCS object, another XCS object, another XCS object, another XCS object. So all of these are XCS objects, and we're merging them, and then we're going to omit. Why are we going to omit? Because getting the daily returns introduces a missing value, yung first row. So we automatically omit that, and let's check how many observations does this final underscore XTS have. Okay, so let's okay, let's first sum how many are the missing values, and then how many number of rows. So that's after we remove class na.omit. So let's run this. So we now have 0 missing values because of this na.omit. So merge prices says 2214, but the final XTS is only 2213. I hope that's very clear to you, class, because we got the daily returns. So we computed for the returns of an object that has 2214 observations. When we get the returns of that, we will have to remove the missing value. Okay, that's why we now only have 2213. Okay, let me pause for a while and please comment if you're able to follow so far. Okay. So far, class, up to this point, are you okay? Okay, thank you. This is just a review class, no? So thank you so much for your participation, for your feedback. All right. Okay, how about the others? I'll give you a few seconds. Okay. Okay. Now, okay, let me repeat, class. Merged prices is an XTS object containing 2214 observations. It contains the prices itself. Final XTS, on the other hand, contains the returns already. So this is what we're going to use, the returns. Okay, and it has 2213 observations. Okay, now we will need also okay, let me just print this. Okay, XS object, we know because the index is our dates. Okay, we will need to create a table data frame for this, where the date is on the first column. So we can do that by converting our XTS object into a data frame. Okay, so we have here, this is our object now, final underscore table, as distinguished from final underscore XTS. So this will be a table. We're using the data.frame, and then we're creating this column date, which is the index from final XTS, and then core data from final XTS. Then row.names is equal to null. Don't give any row names to your rows. And then convert this into a special table, special data frame. Okay, so let's run this. And we can now see that. Let's verify, class. Let's print final table. What's the shape? How many rows does it have? So n row, this is the number, and then the word rows. And then let's get the structure, and then let's again get the type, okay, of final table $date. Okay, so this will give us some information about our final table. It has 2213 rows. It's similar to final extents, 2213, because we're just converting it into table. It's a table class, 2213 rows of observation by 5. Okay. Why 5 class? You have the date. So now we have the date, you have the USD returns, you have VIX, Brent return, and the target also. And what's the class of this object, the date column? It's a date. Okay, we have to make sure that it's a date class and not a character. Okay, so last time we also went to the feature engineering. We said that feature engineering involves preparing our are independent variables, are features. So we're going to use SMA, simple moving average, RSI, volatility, MACD, Bollinger Bands, and ADX. These are very common indicators used in technical analysis and also in forecasting returns. So that's why we're using this. So let me just run this. Okay, I hope you're running it also. All right, and then uh, this was meant class to be run when after the following session actually, no? Kasi we were supposed to finish this last session and then we were continuing with this, so we will have to check if merge prices is there, no? So if merge prices does not exist, the exclamation point here means does not exist, then it tells us to stop and give this comment, merger prices not found. Make sure you run the complete step one code. Okay. However, if this is false, then let's print the merged prices shape, how many n rows, and the head of merged prices, how many first six observations, and then just print the column names. Okay. So this is what this code does. Let's run this. And then you have here plus the first is concatenate here, merge prices, and then shape, right? How many rows? 2214 plus rows here. Okay, the green ones here are the ones to be printed. Here, it's a value, how many rows, and then the word rows. And then these are the first six observations, open, high, low, close, volume, adjusted, VIX, and Brent. And then how many columns? You have here, 22, 14 columns. And the column names here. Okay, so this one, unless you have questions about this class. Okay, no questions? All right, so we actually didn't need to do this because we just run our merge prices. Okay, now we're going to create another object, data for fits, which is exactly final table. The reason is we're going to populate this with the features, okay? And then we'd like to have the final table maintained. We'll need this later on still, okay? So if we run this class, okay, data for fits, how many observations? 20, 22, 13 observations. Just the same as the final TBL class. Let me close this. I have so many open. Okay, so this is data for fits class. This is exactly final underscore TBL. Okay, exactly. Then we're going to populate this with our features. First, what we did was we said that based on research, the lag prices of an asset usually uh, is highly correlated with the prices itself. So here, remember what we're modeling is USD PHP rep, which is the target. Okay, the lag one where we moved it plus we move the we move the value one step. That's our target. So this equation is very simple for k in 1 up to lag max. So from number 1 up to lag max is 3 class as defined above. Okay, what's going to happen here? Create an object called lag column where it will perform the lag of from the data for fits. We're going to get the first column. I mean the second column. The first column is the date, right? We're going to get the USD PHP ret and we're going to lag it. Okay, how many lags? K, and K varies from 1 up to 3. So it will create lag 1, lag 2, up to lag 3. Okay. And then it will create this object again, column name, paste, paste 0, which means you're going to append, you're going to join USD PHP ret lag and then K. And we know that there are 3Ks. So what will happen is that column name will be USD PHP ret lag 1, USD PH ret, USD PHP ret lag 2, and lag 3. And then we're going to data fix class, and then we're going to subset it class here. Okay, the lag call. Here, the data that was generated from lag call, which are the lags of k is equal to 1, 2, 3, will be inserted here in data for fix. So when we run this class, okay, and take a look at data for fix, okay, we now have this one, lag 1, lag 2, and lag 3. And we know class that when we're getting lag 1 class, it will have a missing value here. Lag 2, 2 missing values, and lag 3, 3 missing values. Just to double check class, this is USD PHP ret. Okay. This is negative 7.7798. So this moved here, class. Negative 7.7798. Okay, and then there's one missing value there on top. This one, two lags, negative 4.72. Okay, it's now here on the first line. The three days ago class will now be on the first line, 1.7. Okay, that's why you have 1, 2, and 3 missing values here. Okay, we'll deal with that later. We'll remove all the NAs. Okay, so what did we do next? We got the SMA class, the moving average. So, okay, take note, merge prices class contain 2214 observations, right? We'll deal with this. 2214 observations will create an object called USD PHP close prices. Okay, and it's the closing prices here from merge prices. If you recall, this contains open, high, low, close, volume, adjusted, VIX, and Brent. Okay, XS object containing 2214. Okay, and I hope you recall that when we did the 22 when we merged when we got the sorry when we got the returns class. Okay, let me repeat that. Merge prices contain only the prices. And then we got the returns class. We created the final underscore XTS, where we removed the missing value so that your final XTS will only have 2013. So for this one class, if we run this, so USD close prices will necessarily have 2214 observations, right? Because this is extracted from the merge prices. Okay, so just don't get confused. Okay, so when we run now, we're doing SMA class, which we said is just equal to the roll min. Okay, this is just getting the average depending on the period. Here, SMA short is 5 periods and SMA long is 10 periods. So what it will do is that it will look at the USD PHP prices, okay, here, and then it will get the average 1, 2, 3, 4, 5. The first 5 observations and replace this with the average of these 5. That will be your first value here. The others will be NA, NA, NA. So 4 NAs and then the average of the 5. And then etc. It will keep on moving. The next, this one, up to the 6th, 5 observations. It will get the average and then replace the 6th observation with the average of the second up to the 6th value. Okay, I hope that's clear, class. This is just a quick review of what we have done, class. Okay, so SMA class, both short and long. So if you run this, control enter. Okay, SMA short long here, print long. Okay, so first 9 observations is NA. The last one here is That's a 10th observation. So that will be the average of the first 10. Okay, and there will still be 2214 observations because USD close is from the merge prices, which has 2214 observations. But take note, data, okay, data for Fitch has 2213. So we will have to address that class. How do we address that? Okay, here. Data for Fitch, we're creating another column there, SM short, and what will it contain? Okay, the core data coming from short SMA short XTS. If you recall, class, SMA short XTS or SMA long XTS, this is an XTS object. Okay, XTS object. And then it has 2214 observations. What we're going to do is we're going to match it here. Class. Match it with the index of final XTS. Okay, so the question is, what dates will be included? It should match the dates of final XTS and the dates of SMA short XTS. This one has 2214 observations. This one has 2213 observations, class. Okay, please recall, this is the returns class that contains the daily log returns. And remember, we omitted one here. Okay, 2213 observations, 2214, which will prevail, class? It has to match. It's like an inner join, class. So what will prevail there here, class, is that 2213. So the dates that appear in final XTS will be the one that will be that will prevail, class. So what will happen, class, is that when we insert SMA short in data for Fitch, it will only have 2213 observations because of this function match. Same thing with SMA long, so there will be no problem. Otherwise, class, if you were consolidating or joining two objects that didn't have that didn't have the same number of observations, we will have a problem. Okay, so that problem 2214 versus 2213 was addressed by this match. Okay, match. Okay, I'll run this class, control enter, and check class. No problem, I didn't get any message. Okay, no problem. And check data for Fitch. There you go. SMA short, SMA long, 2214, 2213 observations. Okay. All right. Pause for a while, class. And then once again, request your feedback if you're able to follow. So far, have you added SMA short and SMA long? Okay, good. Thank you, class. Okay. Thank you, class. I always appreciate this class kasi mabilis kayo mabilis kayo mag-respond. And it tells me that you're really paying attention, that you're following the lesson, which I really appreciate. Okay, thank you again. All right, let's go here. Now, as an additional class, the SMA is just the same as the rolling mean. Okay, rolling mean. And I told you, class, to check ano ibig sabihin ng align, no? Ang kagandahan, the advantage of rolling mean, class, is that you can you can what's that? You can modify this class. You can modify the average class. Where's that here? Okay, the alignment class, it depends on how you align it. All right, but we'll not do that anymore. We already did that before. Okay, so sorry, this was double class. Kindly just delete this. Okay, it was repeated, no? It's already here. Okay, then we did RSI class. RSI, which is momentum. I'll leave you, class, to look at the details of the indicators, okay? We're focused now on creating our machine learning model. So what we did last time was to use this function RSI, relative strength index. So this is from, as I said, TTR package class. And then very straightforward class. Just use this XTS object containing 2214 values of closing prices. Okay, so when we run this, same thing, RSITS, XTS class, RSI, it will also have 2214. Where is that? Here class. RSI 2214 also. No? And you notice 2214, unlike SMA class, it starts on the 15th. Okay, so it does not include the 14th observation. Okay, so take some time class on your own to see or check what gives for RSI, relative strength index. We discussed this last time. It's for momentum. Okay, so here, once again, we're going to append this to our data for fits. Okay, and we're going to get the core data. Okay, but we're going to match the index of our final XTS, which is 2213 observations, and the index of the RSI XTS. You might be asking, why aren't we using final underscore TBL? Cannot be class because, and that was my mistake last time class for the Bollinger Bands. I noticed that I had final and then underscore TBL. That's why if you recall, it was not running class. And even before that, I was telling you to please make sure that this is final XTS. Okay. And why are we not using data for fits class in order to make sure that we have the same number of rows? Data for fits does not have the data class. Where's data for fits? Sorry. Data for fits is also not an XS object. Notice the index is not here. Okay, so that's why we can't use data for fits. Okay. All right. So once again, run this class. Then quick review only. And then again, data for fits class. So we now have RSI here. So slowly but surely, we're building up our features, and this is called feature engineering. And then we do MACD, which is a really more powerful, let's say not powerful, more expansive indicator, because RSI only looks at momentum, as SMA looks at trend. This is a combination of both momentum and trend, MACD. And we ran this last time. We said that there are three parameters that we need to show: N fast, N slow, and N sig. We already defined this: MACD fast, okay, MACD slow. This is 26, this is 12, and this is 9. And then the type of MA is EMA, exponential moving average. Okay, that's why I said before that we did not anymore use EMA as a predictor. We just use SMA. The difference between EMA and SMA is that EMA class gives, SMA is equally weighted. So SMA 5, you get the average of the 5 observations, and their divisor is 5. So 1/5 times each of the values. Okay, so that's equal weighting. For exponential moving average, you give more weight to the later values. So more weight to the value yesterday as compared to the value 10 days ago, for example. Okay, so here we first create the list, and then we created this object, MACD, first the list, and then this object. We're making it an XS object from the list, and then we order it by the index of merged prices. Okay. All right. Then change the column names. We run this, and then once we have created our MACD XTS, which is this one class, MACD XTS, which is 2214 observations again. So we have here your MACD line and your MACD signal, which is the difference between your fast and your slow. Okay. All right. So this one class, we now include our MACD line and our MACD signal. Same thing, we get the core data, okay, of from MACD XTS, get the column MACD line, and then again we have to match it with the with the final XTS. Okay, MACD XTS. MACD XTS has 2214 rows. This one has 2213 rows. Okay, so that there will be no error because data for fits has 2213 rows. Okay, so that's the rationale why we're matching. Okay, run. Okay, so we now have here data for fits. Okay, we now have the MACD line and then the MACD signal. And it's okay. Okay. All right. Let me close this. Okay. So after MACD class, we have the Bollinger Bands. This is where I made the mistake last time. So here, we first create this XS object. Okay. Bollinger Bands. We're again using the closing price. And then we have defined the BB period. It's 20. And then we have to define the standard deviation. And this is a default usually. So if we run this, okay, and we check the BB bands XTS, what's inside this one? Okay. So you have down, up, moving average, and then a percentage of the Bollinger. Okay. So we have the values there. And it's also 2214 class, if you take note. So we need to make sure that this matches with the final XTS. Okay. So we need to compute class. Okay. We need to compute the up minus the down. Okay. The up minus the down, and then divide it by the price. Okay, so let's run this now. BB width, and then BB width class will also be 2214. There, 2214. And then this is now the formula. Okay. Up, down divided by the price. Okay. And then once again, class, we do this. Core data of BB width, but then again, match class. Match. Okay. Now, last time, I noticed when I reviewed why I was having a problem with that, is that this was TBL class. Okay, and this will really generate an error because there's no index for final underscore TBL because it's a data frame. It's not an XS object. Okay, so if I run this now, okay, there should be no problem. Okay, here. Okay, let me close this, and just go to our data for fix. Now we have our Bollinger Bands here. Okay. All right, good. Okay, again, class, this is just a review. Again, let me pause for a while and seek your comments, class, if you're able to follow. Thank you, Jerry Lane. How about the others? Yeah, thank you. Sap, thank you. Okay, good. Sophia and Janine. Appreciate really your feedback, class. Alice. Okay. Okay, so let me continue, class. I hope the others are able to follow. Okay, thank you, Ace. Should you have any questions, class, you know the drill. Please don't hesitate. You may ask. Okay, and the ADX class. This one, that's why we had to maintain or we had to preserve the USD PHP pool. For ADX class, for the average directional index, we need the high-low close values. So from the merge prices, we get high, low, close. Remember, class, that the merge prices contains the prices class. That's why I named it prices. Okay. And then this is an XTS object. So what we generate here is also an XTS object. Okay. So, and then change the column names. Just make it high, low, close. And then perform now ADS XTS. Performing the ADX function, okay, which is USD HLC. Okay, this is high, low, close, and then the number of periods. If I run this class, everything here, okay, I leave you class to study what ADX does. And then same thing, class, ADS XTS, ADX XTS has 2214 observations. We'll just have to make sure that it jives with the data for fix, which has 2213. So we append ADX here, and then we get its core data. Okay. However, the number of observations should match the match the final XTS and then the ADX XTS. They should be matched. 2014, 2214, 2213, what will prevail is 2213 for it to be matched, okay? 1:1. All right, so we run this and then take a look again. No error, right? Take a look again at our data for pictures, okay? So we have now the last column at ADX. There we go. So we have many NAs class. It's okay because that's really part of computing for your uh, technical indicators. So what we do now, one last thing class, volatility panel, sorry. So for volatility, okay, I did some changes here. What I gave you last time was core data volatility. I made a mistake here in that I didn't check class. So here, let's create the object volatility ball. Okay, so this is from zoo roll apply. We could have used class the function SD. So there's a function SD from the TTR, and it also does the same thing. Okay, only that roll apply has the distinct advantage of for us in dictating how the standard deviation is to be computed. Okay, so if we run this class, so I added the structure, and you notice this is not an XS object. So last time what I provided you with was core data uh, volatility. Okay, core data, I think volatility. However, it's not. However, it ran class last time. When we last met, it ran. So surprisingly, it ignored the core data because you know that core data is used for an XTS object. But this is a vector class. So anyway, just to be consistent with the type of data, I changed it data for fits, then dollar, insert this column volatility, and then which is just vol. A vol is just a vector, so you can just uh, copy it to the last column of data for fits. Okay. So my apologies, class. Although it worked, no? What did not work is the Bollinger Bands, and the reason is again, I was so careless in my code here, just to show you. Here, index final TBL class. So I made a mistake there. It should be XTS. Okay, then, so where are we now? So let's run this class. Let's run this, and have I run it? Okay, wala pang volatility, no? So let's run that here. Okay, so it now includes the computation for the standard deviation of the prices for the past 10 here. Past 10 observations class. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So just like class rolling mean, where you include the last observation. So you get the standard deviation here. Okay, so that's your rolling volatility. Okay, so we have included all now our okay, we'll be able to start with the good. We'll be able to start with the LM. We're now able to include all the endogenous variables. Okay. Now, why did I call it endogenous? Because those variables, the SMA, the RSI, the MACD, the volatility, the ADX, the Bollinger Bands, they were all derived from USD PHP, right? The formulas class. For example, SMA is just the average first first five average of uh of your USD PHP ret. So they're all based on USD PHP ret. So they are technically endogenous variables. Okay. Our only exogenous variables are VIX and Brent. VIX and Brent. So here, just just like last week, we called it VIX current and Brent current. Okay. So let's run this. And now our data for FIX has this one, VIX current and Brent current. Okay. Okay. Pause again, class. Kindly, your feedback is appreciated, class. Are you able to follow so far? Okay, good. Thank you. Okay. The reason why I think, for me, I believe that this is not an exercise in futility of reviewing the past codes, because repetition makes makes say makes comprehension really a lot better. Okay, so if you have been doing that for several times, then you get more. Okay, thank you, Janine. Hindi nag-error. Okay, yeah, good. Yeah, so we're happy. Okay, that's why I decided to really just quickly repeat. So we have many missing values. So let's just remove the missing values and a.omit and check our data for fits. Okay, now no more missing values. So from 2214, we now have 21,800 at 2180. So how many? 180, 10 at 20, and then so 33 observations were deleted, class. Okay, 2213 down to 2180. Of course, that's to be expected because the metrics, class, the indicators are based on uh, uh, formulas where we remove values from your original data. Okay, so let's create this class, this object called key features, and it's just a vector C. It contains USD ret lag1, lag2, and all the variables that we'll be needing, then VIX current, Brent current, and then the target. Take note, the target is the target variable, that's our dependent variable. So let's run this class. And here we have key features. You have 14 variables, 13 of which are your features. Target is our dependent variable. This is what we're modeling, class. Okay, then what are we doing here? Okay, we're creating this object called final features class. This is just key features class, no? This is a vector class, character vector yan. Now, what we're going to do now is to create data for fits is a data frame. So we're going to subset it, include all the rows, and just include the key features. So it includes the 13 features plus the one dependent variable, which is target. Okay, and then we print final data shape after feature engineering. No volume, it means that we did not use volume class for USD PHP. Had there been a volume, we would have included that because it has been shown in other researches that volume also has an association with your log returns of your asset. And then we print how many rows, and then append the word rows, and then how many columns of the final features, and then append columns, and then the first 6 observations. So let's run this. Let's run final features. Okay, here we go. So these are our final. It has a shape of 2180 rows and 14 columns, and these are the first 6 observations. Okay, so this object we're now using is final features class. Okay, now let's go here, class. This is very important. I'm glad that we have time to start with step 3. Okay, now we begin, class, with the training and testing. If you recall, class, in classification, machine learning for classification, we had to split our data into training and testing. and we use the create data partition or the sample function. What happens there? What happens is that we randomly select, we split our data into two randomly. For time series, that's not possible because as we discussed, time series has a logical structure. We cannot just pick up a date and then put it in our test training and then another date in our testing. We have to preserve class the logical order of our data. So how do we do that? First, let's determine how many rows does our object final features contain. And let's use an 80%, 20% split. 80% for our trained data set, 20% for our test data set. So we use this floor, means from below class, and then take n rows times 0.80, and that will be our train. So floor class means it will start with the very beginning, okay? From the very beginning, and then it will go up 80% of that, of the number of rows. Okay, so when we run this class, okay, so final features, our data has 2180 observations, and then our training data will be 1744. So we will just be using 1744 class, 1744 observations. The others, class here, so let's go here, class. So this is our trained data. We will use final features, and then that's from 1 up to n train, class, this one, n train. So this is 1744 class. And then here, include all the columns, class. So from number 1 up to 1744, that will be from for your train data. And for your test data, again, it will be from the final features, and then n train plus 1, okay? N train plus 1. So 1744 plus 1, 1755. You start with 1755 up to the total number of rows, 2180. So from the row 1755 up to the last row, that will now be in with your test data. Okay, and then here we just print training set, how many rows, okay, and then we just count 100 times number of rows of trained data divided by the total number of rows, okay, no decimal place. Okay, same thing with the test data. So it will print now how many percent. There you go. 1744 for our training data set, 80%. Test data set, 436 observations, 20%. So it preserved what we indicated here, the floor value. Okay, so quickly, class, comments again, please, if you're able to follow. Comments, please. I hope I'm not going too fast. Any clarification? Okay, good. Thank you. Okay. Some more feedback, please. Okay. Notice, class, I'm already giving you the codes because we don't really have time for I don't have time to ask you or request you to copy the codes for at least some of them. Okay, so I apologize for this, class, because I realize that it's really better if you're writing some of the codes yourself, because it gives you a sense of writing it. Perhaps what you can do is just, for example, this one, you copy this outside, delete it and copy it outside, and then try to write it on your own, okay, as practice. All right, so let's go here now. Okay, here we're just checking, class, if the data for fits, class, okay, is it if it's equal to, if they're not the same, not equal to the to the end rows, then give us a warning, class, that the row counts okay, has this number of rows, but the final features has this number of rows, and then you have to proceed carefully. Now, why is that, class? Yung data for fits, class, remember, it's the same as the final features. Okay, so the final features row is the same as data for fits, and the final features should also be the same as n rows. So they should be the same. Okay, so if I run this and there's no comment, it means that we're okay. Okay, I did not put here any comment if it's correct. I only place a comment if there's a discrepancy. All right. So here, class, in this code, okay, take note, this is not train data, class. This is train dates. We just like to see, okay, where the dates are for our, okay, this is very important later on if you're doing your thesis class. You might need to know, or you might need to determine, for example, you're doing a paper where you're classifying pre-COVID, during COVID, and post-COVID, or during Russian-Ukraine war. These are what's being done now by students. Okay, so you need to know, class, the dates. Okay, you have to check whether your pre-COVID is really from, let's say, February 2020 up to 2021, a certain April 2021. Okay, certain like that. So this is how you do it, class. So we have this train dates and test dates. Okay, so we're using data for fits. Okay, we're using this class because it has a date. Okay, data for fits class. This one. It has a date, and we would like to check. Okay, what is from 1 up to train? Okay, what is from 1 up to train? And then for the test, it will be n train plus 1 up to n rows. So if you run this, okay, and then print train per period, okay, so we have subset this, right, class, from 1 up to n train. N train is 1744, right? And then sa date column class, okay, we want to get the minimum. So the minimum of train dates will be the first observation, and the maximum will be the last observation, the end train. And on the other hand, the minimum for test date will be the last day of a train plus 1 here. And then the maximum is the test dates. Okay, if you run this class, okay, you can see that these are numbers. These are numbers. Okay, why are these numbers, class? Because in R or even in Excel, dates are represented by numbers. So this one has a corresponding date. So we can replace this by as that date 16486, as that date 19363, 19366, 2084. And you notice, class, 19363 and 19366, that's the end of for the training, and then here 19366. Why 3 days, class? Because 64, 65 most probably were Saturday, Sunday. Kaya 366 dito nagsimula. Okay, and then we in R, and so it's in Excel, number 1 pertains to 1970-01-01. That's the default, class. Okay, so the number 1 refers to 1970-01-01. So if you run this class, control enter. Okay, these are the dates now. Okay, so for the training data set, it's 2015-02-20 up to 2023-01-06. For the testing, 2023-01-09. So that's January 9 class. So that's we can check class here. We can include, so print class for the train period example here as that date. So here it will print the dates, right, class? Same as above. And then we can use weekdays. We can ask R to convert this date here into a weekday. Same thing with the test data set, class. So this is just nothing that we're just including. So this is not rocket science code, class. It's simple. We're just including the weekdays, class. So if you run everything here, I'll just run here. Control enter. Okay. So our train data set started with a Friday. So this was a Friday, class. I'll just run everything. Okay, this was a Friday, and then this is also a Friday. Friday, and a Friday. For the test data set, this is a Monday, which, okay, at least we have the confidence that this is correct, okay, because the training and the testing should not coincide, class. Okay, this is a Friday, and this is a Monday, and this is a Friday too. And nagkataon lang, class, na na Friday, no? It doesn't mean that it will always be a Friday. All right. So as I said, class, why chronological, class? Because, okay, we cannot do random splitting. Okay. All right. So just by way of just to remind you, class, that our trained data, okay, is from final features from 1 up to and trained the 1744, and then our test data is also a subset of final features. Okay, this is from 1745, I think, up to the last. Okay. All right. Now we need to create this matrix because later on when we go to XGBoost, we need a matrix class. Okay. So here X underscore train. Okay. So as that matrix, okay, we're going to create a matrix from the train data class because we're separating now. We need to separate the features, the independent variables from the dependent variable here. So as that matrix train data, okay, all the rows class, and then negative which names train data is equal to target. So what does this mean, class? Do not include, okay, the names of your trained data that's a target. So that's what this means, class. So it will now create an object, a matrix, which contains only your independent variables, your target variables. And same thing here, class. Your Y train will just be, okay, will just be this will be an XTS object, class, because trained data is trained data is not an XTS object. Trained data is a data frame, class. Okay, so I'll run this, control enter. So let's first check, class, what's X train? What is X train, class, and where is it located? As that matrix, class. So take a look, class. Is it a data class? X, capital X train. Okay. Here, class, no? Okay, it's under data. It's under data, but if you take a look at this, it's numerical class. Here, class. It's a matrix class here. So it only contains USD PHP, log1, log2, log3, SMA short, long, RSI, MACD, until Brent current class. It does not include your dependent variable target. Okay, so I hope that's clear, class. And then let's just run everything, class, here. So if we check Y train, class, Y train, where is Y train here? Okay. Let's view Y train. I'll just view it here below. Control Alt I, view, small y, and then train. Okay. View it, control enter. Okay. So what's it, class? It's only a it's a vector class. Okay. It's just a vector of numbers. So Y train. And these are the target values. Okay, so same class with the X test is also a matrix. Yeah. X test. Where's our X test? Here, class. It has 436 observations, class. Why? Because from 1745 up to 2180, that's 436 observations. Same thing as same thing as X string, okay? The same class, matrix then, but 436 observations. Okay, quickly class, comment if you're able to follow. Why did we create this X train and X test? These are matrices class, and we're going to need them for XG boost. Okay, so we created them here already. Comment please, class. Are you able to follow? Any questions? Okay, good. Just remove this. Okay, thank you. I noticed that only 3 of you responded. Okay, I'll give you a few more seconds. Maybe you're running. Okay, all right. So let's now go to our first model. This is not a machine learning model yet. We're going to compare our multiple linear regression with machine learning. Okay, so linear regression class. Okay, so this will be our baseline. It's simple and it's very interpretable class, and it assumes a linear relationship. Okay, so this is our equation. Our target sub t is equal to beta null plus beta 1 times our log returns for log 1, log 2, log 3 plus SMA, smart, short, long, RSI, etc. Okay. So, okay, now this is very important class. So let's set that seed. We will now be discussing cross-validation. I haven't discussed this with you. I have to be able to discuss this with you now. Okay. So let's create a seed class. And then our end train, just to remind us, we have 1744. And then we're going to discuss now what we call cross-validation. So I provided you here, class, with a site. Okay, let's go here. Cross-validation. So what is cross-validation, class? Control C. Kindly open that class and open that site with me as I discuss this very important process called cross-validation. Okay, and oftentimes in machine learning, it's used. Okay, here. How to cross-validation with time series. So first here, it's a cross-validation with a cross-sectional data. Okay, do you see this, class? Do you see the diagram? Okay, so what happens here, class? When you do cross-validation, okay, for your trained data set, what you do is to split again, create another quote-unquote training and testing on your trained data set. Okay, so the testing data set does not have anything to do with this one, class, with the cross-validation. Okay, so take note here, it starts with trained data set. When you do cross-validation, class, okay, let's say cross-validation, it depends on how you want to do it. You can do it tenfold. Okay, you can do it eightfold. Let me explain what the folds are. You can do it fivefold. So in this case, we're using fivefold cross-validation. So how do we do this? When you do cross-validation, let's say fivefold, you split the data equally into 5 here. Okay. So by the way, this is only your trained data set. Huh? Here it's you're testing only for this trained data set. Okay, so what happens here? Okay, so you split your data randomly into 5, no? Five groups, 1, 2, 3, 4, 5. So this group, class, will become a testing data. So what does that mean? You run the model, class, using these 4 training data. Okay, and then when you have the model, you now compute for the use the model, class, for this one, and then compute the Ramsey, let's say the MAE, the R squared, etc. Then after that, you create another one here, class. this time, this will be your test data set. So these four others will still be your trained data set. Okay. So notice, class, that every data becomes part of a testing. Okay. I hope you, sorry. Is it this way? No, it's this way. Fold one, class. So this is our fold one, class. So this is our fold two now. So this one, you make this your test data set, class. And then you use this for others to create another model. So in this case, K is equal to 5, class, means you are creating 5 different folds. Okay, so that means you're going to create 5 different measures of Ramsey, 5 different R squared, 5 different MAE, okay, etc. And then what you do, class, is you get the average for each of the 5 here, for each of your 5 folds. So what's the average of your Ramsey? You have your Ramsey root mean square error here, 5. You get the average of that. That will be your performance. Okay. So you get the performances for each of your splits, class. Okay. And then you get the standard deviation of your Ramsey and your metrics. So you'll have now a measure for the mean and the standard deviation of your metrics, class. Okay, so you have what happens is that you sort of have an initial output. And then after that, class, you again use all your trained data set, create a model again, and then after you create the model, that's the time you use the original test data set, the actual test data set. So you have cross-validation, 5-fold cross-validation. You're actually doing 6 models. So this is one model, and then you get the averages, and then use everything as originally designed, everything, class, as your trained data set, and then create a model and then test it on your testing data set, the one that we created a while ago. Okay, so that's your k-fold cross-validation. However, you cannot do this for time series, class. Okay, so let me just end in this. You can't do this for time series. Why? Because here, you're randomly splitting your data, right? So to do this for time series, you go down here, class, here. Okay, this is your time series now, class. Okay, so how do we do this, class? Once again, we split our data, same thing, into 5. But the splitting should be, class, by date. Okay, let's say we equally split it by 5, and then, so we have now 5 blocks of code. Okay, so let's say if we split it into 5, let's suppose, for example, there will be 300 observations each, example only. So what will happen is that the first model, class, will be, so we're using k is equal to 5 also, 5-fold, no? 5-fold. So the first observation will be, the first strain will be, remember, each fold is 300, for example. Assume that we have 1,500 observations. Okay, train data, class, 1,500. Okay, and then if you make it 5-fold, then that means 1,500 divided by 5. So that means each fold is 300. So the first model will get the first 300. Okay, create the model just 300, and then we test the next 300. Okay, only 300 will be our training data, and then we test that for our 300 testing data here. And then next, okay, you include now the next 300. Okay, so you now have, class, 600. Take note, class, that the test data set will always be, quote unquote, the future with respect to your folds. So take a look at this, class. The test data set here, since this is chronological, it cannot be ahead of your train. You do not use a future data class to come up with a model, okay, for your train. Okay, that's wrong. You cannot use because that's like peeping into the future. So take a look at this class. So here, you're now using four 300 values. The first fold, okay, first 300, second 300, third 300, fourth 300 class. So that's all in all 1,200. You're using this, you create a model now using 1,200 observations, time series class, sunod-sunod yan. And then after you get the model, you run it on the test data set on the last. So that way, class, you also have 5 models here, class. 5 models. And after this, after you get the average of the results, okay, you once again use all the trained data set, create a model using all of this, and then run the model on your test data set, actual data set. Okay, it's already time, class. So let me just, okay. So for next meeting, class, okay, I'm glad that we were able to, I gave you this class, no? Kindly try to run this because this one, okay, just follow this class, okay, it will give you the train, the chaining class. We call it the chaining window class because the it's like creating windows and then they're chained to each other. So follow this class and just take a look at it one by one, class, up to, okay, maybe up to here, okay, up to this point, class, even up to this one. Okay, so I hope you'll follow that. This will be the our discussion next meeting. Okay, we have a long way to go, class. We'll just discuss how we'll be able to try to squeeze in the rest of the lesson. Okay, all right. With that, class, I'll stop recording.